is connected by blood vessels. In cartilage, I said there will be some mother cells called as chondroblast cells. In Latin, the blast means sprout. You know what is sprout? Develops into. That's why the cells whichever called as blast cells, they are immature. Because in the future, in the further development, that blast cells, it may be chondroblast cells, osteoblast cells, they will develop into specific type of cells. So that's why in this bone, we can find osteoblast cells. Where we can find that osteoblast cells? In the middle of this solid region. You know very well the bone is very hard. That is due to presence of high concentrations of calcium salts. And in this bone, we can find one specific system where other tissues are lacking. That is Haversian system. Haversian system. In cartilage, the outermost layer of the tissue is covered by perichondrium. Similarly, this bone is also covered by periosteum. The meaning of peri is peripheral position. Peri means surrounding, covering. So this is periosteum. At the same time, the inner surface of this solid bone, solid structure, which is opened into that lumen, marrow cavity, that end, that is another end. If I take the fraction of that solid structure, I am telling if this is the outer structure, outer surface, this is covered by periosteum. The inner surface is covered by endosteum. Endosteum. Endo means inner. Peri or ecto means outer. In between that periosteum and endosteum, we can find Haversian systems. Through these Haversian systems, the blood vessels are connected. Inside that Haversian systems, we can find lacunae. That is not new word to you. Yesterday also I said, lacuna means a layer which covers some cells. In chondrocytes, I told you, 2 to 8 or sometimes single cell will be there inside that. So that lacunae will be there. Inside the lacunae we find osteocytes. So to understand about that Haversian system, the main important thing is the bone must be able to receive the nutrients through the blood. And at the same time, there must be some communication between the outer surface and marrow cavity. If I tell you, if this marrow cavity is completely enclosed, in that marrow cavity, don't forget, RBCs are developing. If that RBCs develop there, how they will come into the bloodstream? So that's why there will be some connection. There is continuously, there is the spreading of distribution of blood vessels in that solid structure of bone. That structures are absent in cartilage. Blood vessels are absent inside the cartilage except perichondrium. But here, throughout the solid structure of bone also blood vessels are present. For that, in that solid structure, if blood vessels are present, you can imagine they have some pores. So that pores are provided by Haversian system. There will be some canals. We call the canals as workman's canals. Workman's canals. So Workman's canals are present in Haversian system. Haversian system is present in between the endosteum and the periosteum of bone. If you get the word Workman's canal or Haversian system, in animal kingdom, in this world, the two words are related to only bone. So immediately you have to recall the structure of bone. We can see the detailed structure of Haversian system in the regular classes. Now, yesterday, I didn't tell you examples for irregular dense connective tissue. This is one example, periosteum, perichondrium. So perichondrium, periosteum is made of dense, irregular connective tissue. For dense regular, I said tendons and ligaments. So you remember that. Now, let us see third type of specialized connective tissue. That is blood. Specialized connective tissue. In this, cartilage, bone, and blood. These three. Now, let us see about the blood. Study of blood, hematology. Study of cartilage, chondrology. Study of bone, osteology. This blood is having matrix. This matrix is very common in connective tissue. I said in connective tissue, the matrix is more in amount, but here the matrix of blood is without fibers. No fibers. Whereas in tendons, ligaments, cartilage, in cartilage I said the refractive index of the fibers and ground substance will be same. So we cannot see that fibers, but fibers are present. But in the blood, the matrix is without fibers. Collagen fibers, elastin fibers, nothing. That is one difference between the matrix of the blood and the remaining connective tissues. The second important difference is the matrix of all other connective tissues are very stable. That is stationary. That matrix will not move. But here, the blood matrix will flow from one region to another region, that is movable. Because of that moving, flowing matrix of blood, the blood is called as fluid connective tissue. Fluid connective tissue. Why we call it blood as fluid connective tissue? Because the matrix is flowing from one part to another part in the body. So these two are very important differences. In the same connective tissue, all other tissues are one type, the matrix of blood is in another way. Right. This matrix of blood is called as plasma. Plasma. Now, if you take the blood can be studied in two parts. So the blood, the matrix of blood is called as plasma. In that plasma, different cells will float and move like a stream. They are called as formed elements. Formed elements. In some books, they will give that as blood cells. So these two are the main parts of blood. If we take the blood, if we remove the cells, that is called as plasma. Blood minus cells called as plasma. Similarly, if you take plasma and remove clotting factors, we call that as serum. In some topics, I think that word came in your biology. Whenever the snake bites, we take vaccine. That vaccine is nothing but anti-venom serum. Serum means that is the plasma devoid of clotting factors. You know very well, clotting factors help us in blood clotting mechanism. That clotting mechanism will prevent loss of blood during injuries. Let it be, I will explain that also later. So if you take the plasma first, this plasma, 92% of the plasma is water. The remaining 8% consists of organic and inorganic substances. In this organic category, whatever we take the food, after digestion, from the small intestine, the digested food will go to every part of the body, every cell of the body. At the time, how the digested food will reach every cell? Through blood. Through blood in the sense, not inside the blood cells. That will be with the help of plasma. So if you take the blood smear, some amount of blood, in the blood, in the plasma, we find the digested food. That all the digested food, it may be fatty acids, it may be amino acids, it may be glucose. So like this, any protein, I explained their clotting factor. The clotting factors are proteins. Along with the proteins, we find some fibrinogen, hormones, all that will come in this organic category group. So what will be the organic substances present in plasma? That is glucose, amino acids, fatty acids, enzymes, hormones, clotting factors, all these will come. And in inorganic substances, we can find some salts in the plasma. It may be magnesium, maybe calcium, bicarbonates, chlorine. So different types of other minerals are also present in the plasma. Now here I will tell you, in organic substance, yesterday I said one substance which will keep the blood fluid in condition, that is heparin. That will also come. Heparin. So what is that heparin? That is anticoagulant substance. Till now I said factors which are helping in clotting is present in plasma. At the same time I am telling heparin, which is anticoagulant, is also present in plasma. That means both, which prevents clotting, which helps in clotting, both the factors will be in the plasma. That depends upon the situation. They become active. And along with that, we find albumin, globulins. We are talking about plasma, right? That's why plasma albumin, plasma globulin, we used to call them like that. These albumins will maintain the viscosity of the plasma. If albumins are more, the blood becomes more viscous. So that's why albumins play a very important role. And if you see the chemical nature of plasma or the blood, the pH will be 7.4. So the pH of blood is 7.4. That is slightly alkaline or acidic? Alkaline. So slightly alkaline. So that is the nature of blood. Now if you come to formed elements, there are three categories: RBCs, WBCs, platelets. RBCs are called as erythrocytes. WBCs, leukocytes. Platelets, thrombocytes. So other names. RBCs are called as erythrocytes, WBCs are called as leukocytes, and platelets are called as thrombocytes. Now, if we take the total blood, in the total blood, how much of space in the blood is occupied by RBCs? That is called as hematocrit volume. What is hematocrit volume? That is the amount of RBCs present in blood. So if the hematocrit volume is low, the meaning is the person is suffering from respiratory disorders. Means that person cannot transport the sufficient amount of oxygen to the target cells because of lack of RBCs. So that is hematocrit volume. Now, if we talk about these RBCs, in the initial stage, in the embryonic stage, spleen and liver helps in production of RBCs. So, in embryo, spleen and liver, these two will help. But after taking birth, from infants to adult stage, bone marrow will help. Red bone marrow. So the process in which RBCs are produced, called as erythropoiesis. Erythropoiesis. That's why in adults, bone marrow is called as erythropoietic organ. In embryonic stage, spleen and liver are called as erythropoietic organ. That's why we see the difference in the chemical structure of fetal hemoglobin and adult hemoglobin. In adult, hemoglobin will contain 4 polypeptide chains, 2 are alpha, 2 are beta. But in the fetal RBC, the hemoglobin contains 2 alpha and 2 gamma chains. So that means in the production of hemoglobin in fetus by spleen or liver, faulty hemoglobin will be developed. That's why again at the time of taking birth, in the infants, neonatal babies, for the first 3 to 4 days, completely the hemoglobin will be replaced by new hemoglobin developed by bone marrow. So, newly born babies will suffer from jaundice. That's why they will keep that 1 day, 2 days baby in the incubators, in the hospital nowadays. So that happens. And generally, if you see the number of RBCs for every cubic ml of blood, there will be 5 to 5.5 millions of RBCs. How many RBCs? 5 millions to 5.5 millions of RBCs in 1 cubic mm of blood. You can express that as mm cube or cubic mm. After development, the RBCs can live for 120 days. There is a lifespan of RBCs. That means nearly 4 months. That's why if you listen in any blood donation camps, they will ask you previously when you donated. We have to maintain the gap between two donations because our bone marrow takes some time to produce new RBCs, 120 days. After the death of RBCs, they will be destructed in one organ which is called as graveyard of RBC. So the dead RBCs will be destroyed, destructed, and whatever the necessary substances are present, they will be recycled in bone marrow for production of new hemoglobin or RBCs. That is spleen. So spleen is called as graveyard of RBC because the dead RBCs will be destructed in spleen. Now I will tell you, if the blood is flowing slowly in the circulatory system, or if the blood stop moving, that means resting blood or slow moving blood will show one character. These RBCs are heavy in number. When they are moving slowly, they will pile up one upon the other. That means they will appear like a stranded structure. So one upon the other, the RBCs will fix. We call that structure pile of RBCs as Rolex. So Rolex means piling of RBCs due to resting condition or slow moving blood. These RBCs contain hemoglobin. This hemoglobin, HB or Hg, this hemoglobin must be minimum quantity, 12 to 16 mg per 100 ml of blood. Every 100 ml of blood must have 12 to 16 milligrams. If the quantity of hemoglobin is reduced in any person due to lack of iron or due to malnutrition or due to excess of loss of blood, that condition is called as anemia. So we have to maintain the same quantity of hemoglobin. Then only the blood can transport sufficient amount of oxygen to all the body parts. So maintenance of number of RBCs is important. Maintenance of hemoglobin percentage concentration is also important. And there are two extreme conditions. Sometimes in some people, RBCs count will fall. We call that condition as erythrocytopenia. Erythrocytopenia. Some conditions, in some situations, some people will show abnormal increase in RBCs, excess of RBCs in number. That is called as polycythemia. So polycythemia is contrast to erythrocytopenia. Erythrocytopenia means low in number. Polycythemia means more in number. That is related to RBCs. If you take RBC structure, each RBC will be very spherical. They are biconcave, both the surfaces, concave surface. that is just like a disc. In mammals, in our body, RBCs are without nucleus. That's why RBCs are enucleated. Enucleated RBCs. But two mammals have nucleated RBCs. We have to remember that exceptions also. So in mammals, one camel, another one is llama. So in these two animals, there are exceptions in case of condition of RBC. So remaining in all the other mammals, enucleated RBCs are present. That enucleated RBC, what is the importance? Why that RBCs are lacking nucleus means to reduce the size of that cell, because these RBCs have to move inside very minute, tiny capillaries of blood vessels. So, to reduce the size, diameter, or thickness of that RBCs, that is losing nucleus. So, these are some characters related to RBC. So, one thing is, I didn't explain about the structure of hemoglobin. Each hemoglobin is a conjugated protein. Globin is associated with ferrous group. So 4 irons will be there in each hemoglobin. That's why whenever one hemoglobin binds with 4 oxygen molecules, the saturation levels will be 100%. So one hemoglobin can bind with 4 oxygen molecules. In heavy traffic areas, if we are moving, we lose patience because we cannot provide oxygen sufficiently to the body parts due to polluted air. Because in that area, in the polluted area, oxygen levels will be low. That's why our blood cannot obtain or cannot collect that sufficient amount of oxygen from the lungs. That's why this hemoglobin saturation levels depend upon the concentration of oxygen in that area. So if the oxygen levels are less, saturation levels will be very less. If the oxygen levels are more, saturation levels will be more. And there is one question. If any person visits the peak of any mountains, highly elevated areas, that is high altitudes, in that high altitudes, oxygen levels will be low. So due to that, if the person is habituated to live there, definitely that person must show more number of RBCs, because if the RBCs number is normal, oxygen levels are low, deficiency of oxygen to tissue. That's why that people who are adapted to live in that high altitudes, they have more number of RBCs in a normal condition also, because the oxygen availability is different in that area. That's why the people adapts if they live continuously. If we go for 1 day or 2 days, in our body more RBCs will not generate, will not form. We suffer due to suffocation. So, saturation levels of hemoglobin depends upon that levels of oxygen and also levels of carbon dioxide and carbon monoxide. Because this hemoglobin can bind with oxygen, I told you, due to iron. The same hemoglobin is having affinity towards CO and CO2. If CO is present, if carbon monoxide is present in any area, this hemoglobin will forget about oxygen. That will ignore oxygen completely. So, highest affinity is between carbon monoxide and hemoglobin. Next, second priority is to hemoglobin and carbon dioxide. And least affinity is between hemoglobin and oxygen. So that is very important, and we can study that in detail. Now come to WBCs. These WBCs are called as leukocytes. Just we can find 5 to 7,000, 5,000 to 7,000 of WBCs per cubic mm of blood. You see the comparison, you see the difference. The number of RBCs are 5 to 5.5 millions per cubic mm, but here the WBCs are 5,000 to 7,000 per cubic mm. So drastic fall in, not fall, low in the number of WBCs. These WBCs lifespan is also very less. RBCs lifespan is for 120 days, but here the WBCs lifespan is just for 2 weeks. And yesterday I said, if they become the macrophages, if they become the memory cells, they live for 70 years also. That is different. So they are modified, adapted cells in the body. Throughout our life, they are supposed to be present. Just to recall and remind the information about that microorganism. They will remain in our body as memory cells. That is different. Now these WBCs, for example, if you take one WBC, in this WBC, nucleus will be there. Along with that nucleus in the cytoplasm, some WBCs have granules, some WBCs are without granules. So depending upon the presence or absence of granules, WBCs are divided into two types, granulocytes, agranulocytes. So WBCs are two types, granulocytes, agranulocytes. So these are WBCs. In granulocytes, there are three kinds: acidophils, basophils, neutrophils. In agranulocytes, two types: monocytes and lymphocytes. In the previous class, I said the monocytes will become macrophages, which are phagocytes, which can engulf the microorganisms. And lymphocytes, yesterday I told you when I explained about the plasma cells, memory cells and plasma cells will be belonging to both T and B lymphocytes. Now, have you heard about eosinophilia? That is one condition, eosinophilia, where eosinophils will increase abnormally in number whenever the person suffers from allergic reactions. That eosinophils are nothing but acidophils. So we call that as eosinophils because these acidophils can be stained by using one chemical which is acidic, that is eosin. So due to the staining ability of these cells by eosin, we call them as eosinophils. And they help in allergic reactions, as I said, and the same eosinophils help in antigen-antibody reactions. And if you see basophils, I told you yesterday, day before yesterday, some cells of that matrix of connective tissue, histamine, bradykinin, and heparin. These three types of chemicals are produced. We call them as alarming chemicals, which help in inflammatory response. I told you that type of chemicals, bradykinin, histamine, is secreted by basophils also. Histamine, bradykinin, and serotonin. This is also one chemical. So these three substances are secreted by basophils. In the blood, in the total WBCs, basophils are least in number. Basophils are just 1%. In the total WBCs, basophils number will be very, very less. At the same time, you may get found out which WBCs are more in number. That is neutrophils. More than 65% of WBCs are neutrophils. So like this, I will continue tomorrow. Thank you.
సింబాలిక్ వస్తాను అట్లా అంతేనా